Guys, we're going to talk about systems of equations today. And one thing I like to talk about is we're using real-world applications to discuss what it actually is we're doing. So if you went to the movies, $10 for an adult ticket, $5 for children's tickets. Logan goes and buys 7 tickets total at $50. Let X be what you don't know. You don't know how many adult tickets he bought. And you don't know how many kids tickets he bought. Then we end up getting our equation. Number of tickets plus the other number of tickets for the kids equals 7. Think about it. If you had the pile of tickets, it's adult and kids added together is 7. And then the other one is $10 for every one of those. I don't know how many adults. So 10x plus 5y equals 50. Set equal to y. We've learned that in literal equations, also in solving quadratic form. Linear equations in linear form, in slope-intercept form. You get 2 equations. Y equals negative x plus 7 here. Y equals negative 2x plus 10 here. And we get a number that they cross that. That number is an xy coordinate. That is the x and the y, the adult and the kids' tickets. It's 3 and 4. So what is a system of equations? A system of equations is 2 equations with 2 variables each. Substitution is the method we're going to go over today. We've gone over graphing enough, but I want to talk about substitutions. When you plug a number in for a variable, you can have one solution, infinite solutions, or no solutions. Example 1. What if you get the equation y equals 7 and 4x minus y equals negative 4? You have to take the y that you just got and plug it in. We're going to solve. Notice the y is good. The y is gone, and literally the 7 went into its place. If you look, then you solve, you get 3/4. The answer is 3/4 and for x, and the y is 7. How do we get there? We took the 7 and literally plugged it in, and then you solve it and you put it back into the other equation. Example 2. Here's the first equation. X equals 2y. Y equals x minus 2. Literally plug in where you see the x into the other equation. And then you move. Now we have y equals 2y minus 2, because we plugged it in, substituted it in, minus 2y from both sides, and we end up with negative y equals negative 2. Y equals 2. Plug it back into either equation. It does not matter which one. I plugged it into the first one, equation 1 and equation 2. I should probably label them, which I will in the next slide. So equation 1, equation 2, you simplify it, and you end up with x equals 4. The answer is 4, 2. X equals 4, because x equals 2y. Because we have y equals 2, we've substituted in. X equals 2 times 2, x equals 4. Let's do a little bit longer problem. So equation 1, x plus 2y equals 6. Equation 2, 3x minus 4y equals 28. Step 1, get the variable alone. We have 4 variables, 1x, 1y, second x, second y. I'm going to pick the first x to get alone because that's no coefficient. X equals 6 minus 2y. Step 2, plug it into either equation, the other equation. So we're going to take all this stuff here and plug it in for the 3, in front next to the 3. So 3 times quantity 6 minus 2y minus 4y equals 28. Now we're going to solve. Distribute the 3, we get 18. Distribute the 3 to the negative 2, you get negative 6y minus 4y equals 28. And then we solve. And you end up getting y equals negative 1. Plug that back in. That's the last step. Step 4, plug it back in. Now that's when I started labeling these equations. We have equation 1 and equation 2. You can plug the y equals negative 1 to either equation. It will give you your answer for your xy. So we're going to plug it in. I plugged it into equation 1. X plus 2y equals 6. X plus 2y times negative 1 equals 6. X minus 2 equals 6. And the final answer is x1.